integration, which is Romberg integration. Okay, Romberg integration. Yeah. The last part of integration. Next class, we move to differentiation. Okay, so Romberg integration basically applies the trapezoid equation. Okay. Now, Romberg is an extrapolation formula. Okay, extrapolation, where it used Richardson extrapolation. It used trapezoidal rules. Okay, trapezoidal rules. So trapezoidal rules, as you know, B minus A multiplied by FA plus FB over 2. Okay, it used this integration formula. Okay, it doesn't relate with Simpson at all, only trapezoid. Now, it provides better approximation of the integral by reducing the true error. Now, the difference is, okay, as we know, integration is to find area under the curve. Okay, area under the curve. Last time we had done with trapezoid. Okay, let's say for trapezoid, we know that area under the curve. Okay, trapezoid. Whether n equals to 1 or n multiple. Okay, and it used its specific equation for trapezoid. Okay, this is trapezoid. For Simpson, for Simpson, we still find the area under the curve. Okay, but for Simpson, you have 1/3 and 3/8, right? So 1/3 minimum point is how many points? 1/3. Simpson 1/3. 3 points. Minimum 3 points. So minimum n is 2. Okay, where n, minimum n is 2. For multiple, you should check what are the suitable n for multiple Simpson 1/3. Okay, and 3/8, minimum point 4. N equals to 3. That is the minimum. Okay, plus the rest. Okay, that is Simpson and trapezoid. The one that we did last time. We do one-time integration and we know that the more segment that you have, okay, the more segment that you have, start with error will be lesser, correct? Error will be lesser error, less error. The more segment, the less the error. We go vertically, okay? Trapezoid and Simpson last time. But now, Romberg, the concept is it goes horizontally. Okay, it goes horizontally. Okay, for example, we have this. Now, first level of integration, we use trapezoid. First level integration. Okay, you will have your value over here. Now, Romberg, it goes horizontal. So you will do second level of integration. Integration here, not iteration. Integration. Okay, second level, and later on you will see third level. Your level up to third level of integration. Okay, we go horizontally for Romberg. Okay, now how to do that? We use equations. Again, I differentiate Simpson and Romberg, Simpson and trapezoid last time. We go vertically. Romberg, we go horizontally. Okay, Romberg, we go sideways to reduce the error. Okay. Now in trapezoid, we know that the actual integration, Kr is the exact value. It is the integration of the n segment, okay, which each segment you will have its own h, right? So this integration at its own h plus the truncation error. Truncation error last time, it is the true value minus approximate value. Truncation error. This is not the percentage. If the percentage, you will divide by true value times 100. Okay. This is the truncation error. Okay. Okay. In this topic, where you have different n segments, then you will have different h. Okay. For example, you have n equals to 2 and n equals to 4. Okay. The I actual is still the same. I actual, the true value. Okay. But for n equals to 2, you will have I at h1 plus the truncation of this part. Okay. And this one is I at h2. Different segment has different h. Okay. So eventually, you will get the same actual value of I. It's just different segment. Okay. That is what represented by this equation. Okay. Now, for Richardson extrapolation, in your slide, it might have the explanation how it get into this error value. Okay, you can read and understand, but I will only apply it. Okay, so we engineer, we apply it. If you want to understand further how it gets up to here, you can refer to the textbook, the derivation. Okay. Now, in Romberg, later on, you will see you will have different level. So different level will have their different error. The terms is higher order level. Okay. Now, I explain first. For example, you have these 4 set of segments. First integration, the first level will brings OH power 2. This is first level. Second level, O power 4, H power 4. Third level, OH6. Okay. The first level only, we use trapezoid rules. Okay, first level only, we use trapezoid rules. The rest of the level, we use this equation. Okay, this is for OH4. Okay, I introduce the equation first. Then this is for OH6, the third level. Okay, IN, the IN here means more accurate. Less is, L is less accurate. Okay. Now this is level H8. Usually your level up to H6 only. Okay. Now, what does it mean by more or less accurate over here? We'll go through later on. This is the general Romberg integration algorithm equation. Okay. Now, the J and K over here. J is the, is it here? J estimation. Okay. Here you have N. J over here means J equals to 1, 2, 3, 4. Okay, and K is the level of integration. J going downwards, K going sideways. Okay, so K equals to 1, K equals to 2, K equals to 3. Now this is the OH2, OH4, and OH3. Sorry, OH6. Okay, now we move to example so that you understand better. Okay, we still use the equation from the previous example, the fx over here. Still same A and B. Okay, now for example, single and multiple application. So you have few segments over here with different H. Okay, remember different segment will have different H. Now this integral, the one that you find using trapezoid rules. Okay. Now it asks you to estimate for 1 and 2 segments. It asks you to, let's ask you. Compute improved estimates of the integrals. Now, this one is going downwards. Okay, so we move sideways. Now, this is the equation of OH level 4. This is first step, OH level 2, first integration. Okay, now this question asks you to find the O level 4, OH4, okay, where we know this is the equation. Now, IH2 minus IH1. This is the IM more accurate and IL. Okay, why this is more accurate? Because H2, you see the H2, smaller distance. Smaller distance, more segments, you will have high accuracy compared to H1. H1 is larger distance, less segments, so lesser accuracy. Okay. Now include the value. integration of IH2, I more. Okay, so that's why it put IH2 minus the integration which is less accurate. Okay, now this is because it involves first and second segment. So these two will this estimation. If you find another value within this and this, then you will get another value. Okay, here, this part, it use the n equals to 4 and n equals to 2. Okay, so this one, that is the estimation. Okay, so down here, it mentioned the error. True error will be lesser. Okay, so from here, you see, from the first integration, first level, go vertically, you will get the final value. The lowest error is 9.5. But when you go sideways, the error will be lesser. So instead of increasing the n downwards vertically, let's say here you continue 2, 4, 6, 8 until down. Let's say and in order to get the lesser error, instead of increasing the segment, we go sideways. So go sideways, we just increase another level of integration. You will get lesser error. Okay. No need to have more n. K3, okay, if you want to go to K3, wait, I copy this thing to another slide. Okay, if you want to go to next level, which is K3, equivalent to OH6. Okay, so you must have two values of integration. Now we have two values over here. Using this, you will get your value over there. Then, but OH6, you need to use the OH6 equation. Where is it? This one is OH4. Now here, this is the value. 16 over 15. Okay, I copy to the slide. So to find that O levels H6, To find this integration, you will need to use this equation. Okay, I am more accurate is 1.6 over here. IL is the less accurate. Try to calculate what you get. One 1.6405. Okay, we know that the true value is that value as well. 1.640533. Okay, so now you get that exact true value. If you move forward K level 4, you will get the same value. Okay, if you want to forward K to level 4, you need another value down here. Because you need two values to move to another level. Okay, so if you move to K level 4, you will need another value down here, which then you will need another value down here as well. So you need to add the segment. Add one more segment. Let's say here 8. Then only you can find the K level 4. OH8. Okay, understand the concept? We go sideways. Yes. This one. New value, so you need to find new value over here. Yes. Then from here you get this value. Then using this, you get this value. Then using these two, you get this value. Yes. Below one is more accurate because the H is smaller. Okay, that is Romberg. Okay, take your time to digest first before we move to next example. Which one? Okay.
So then what's the segment is supposed to be? So in this case, they would look at so it's not any English like the total segment you know and so it's given by to get the knowledge of the complement and pathological thesis that I it's simply like the two values and so we subtract anything so then I get
Okay, so this one represents the calculation just now. Higher level, the more accurate. So it will more approaching the true value. Okay. Now we try this one. This example. Wait, before that, I think I should explain to you this one first. The numbering over here. This one. I explain this one first. Okay. Romberg, we know that based on segments, J is the estimation numbers. Okay, going downwards, J. K is going sideways, the level. Okay, so K1, K2, K3, K4, all of these. Now, this one label as integration 1, 1. Make it bigger. Okay, integration 1, 1. So level 1, estimation number 1. Okay. Each level going downwards, level remain. Okay, so you should understand this one because certain question it just asks you to find estimation I13. So you should know which level is that. I13, 3 is the level. So level 3, OH power 6. Okay, so I13, first estimation of level 3. Level 2, okay. The back side is representing the level order. Okay, yeah. Because certain question, it doesn't mention whether OH6 or K13. It just asks you to find I13. So you should know which level is that. Okay, now, to find I13, we go backwards. Let's say the question asks you to find estimation of I13. So you should know what level is that and first estimation. Okay, this is K level 3, which is OH6. Now, in order to reach to I13, you need I12 and I22. To get I12, you need this. Okay, so to get I22, you need 21 and 31. So you need those values. So you will go backward to estimate what are the values that you required in order for you to find the I13. Okay, and then what are the segments involved? Okay, segments over here, you can see this one. It doubles up. It doubles up the segment. 1, 2, 4, 8, and 16. Okay. First level, use trapezoid equation. Second level and above, use Romberg. Okay, the equation just now that I mentioned, level 4, which it requires 4/3 I1. Okay, I more minus 1/3 I less. Okay, this one, okay, listen. You will not be given this equation. You will be given this general Romberg equation, in which if you start everything, you will get this equation. Okay, let's say this one is IH4. I level 4, level 2. Okay, means let's say I12. You want to find for I12. Yeah, I12. Okay, now sub into this equation. K is 2. What's there? What is that sound? This one IJK. IJK. Okay. Now IJK. So this is your J. This is your K. Okay. Now for K is 2 minus 1. I J is 1 plus 1. Okay. K2 minus 1. Minus I J is 1, 2 minus 1 over Okay, if you sub that, you will get the same equation. 4. And this one equals to 3. Okay, so you will get the same thing. Okay, you'll get the same. So if you don't remember this equation, you can sub into the main general equation. Huh? Easy.
Oh.
Yes. Can, no worry. Easier. Okay, let's try the example. Once you know the step, it will be easier. Because this one, it used trapezoid rules only for the first part. Now this, find the definite integral for the following function. This is your fx. Okay, this is your a, this is your b. By right, this one is close first. Okay, this one it already gives you the answer. So we find level for each level. Now for first level, k equals to 1, which OH2. 1, 2 for the segment. Okay, the H, how to find the H? Alright. Okay, B minus A over N. That's how you get this value. B minus A over N. Now, first integral, level 1. This is I1, 1. This one using integration, trapezoid integration. Segment, this is the segment given. In this one, it's given. Okay, for first N is 2, 4. A and B is 2, 4. H is 2. Okay, the H is 2. Then you find the trapezoid using trapezoid. Okay, your FA is using this function. Then plus FB, sub your value into the function. Then you will get the first integration. So you get 3.41. Okay, first is simple. N equals to 1. Straight away you sub into the trapezoid equation. Don't do the rest yet. Only the first segment first. Okay, first segment, we know N equals to 1, so H2. Now, how about the rest? You need to identify each data that you require. Okay, for N equals to 1, you only have A and B. Okay, A and B, which is 2 and 4. Okay, but when you move down, when N equals to 2, okay, now N equals to 2, you will need another point, which is this. Okay. Now in the equation, if you have my slide, my previous slide, here I mentioned as M1, middle point number 1. Okay, so here the M1, how do you find the M1? Huh? We have H over here, 1, right? So 2 plus the H, you will get the M1. Okay, M1. So H is 1, M1 is 3. We find all data first. What are the data that you need? Okay. Then moving downward, when you have 4 segments, okay, now you have 4 segments. Add more. Okay, now this I label as midpoint number 2, midpoint number 3. M2, M3. So what is the value of M2 and M3? Okay, M2 using this value of H, which is 0.5. When you have 4 segment, your H getting smaller with 0.5. So your M2 is 2 plus 0.5, 2.5. So M3 would be 3.5. M3 would be 3.5. Because you will need the FM1, FM2 later on.
Find
The first level. This one. This one and this one, you need the FM, f-axis value. Okay, why we need to identify the point first? Because later on, you will need to find FA, FM, okay, all the FMs, FB. Okay, why? Because the first level, we are using trapezoid's rule. So trapezoid's rule, for N4 segment, this is multiple. Multiple, you need all the f-axis values. Okay. Yes. Green color function. This one. Yes. Single application of trapezoid. Yes. This one only one segment. So you only have A and B. Okay. Okay, for FA, you should be getting this value. Okay, so these are the data that you require to find the first level integration, OH2. Okay, I bring to next slide, this value. This value I bring to the next slide. Okay, next step. Step number 2 is to find the first level. Find OH2, which is K equals to 1. Okay, this part using trapezoidal equation, trapezoid rule. Okay, using trapezoid rule. So I11 just now is the H multiplied by FA plus FB over 2. This one single application. So we straight away use the single application trapezoidal rules. And this is the n equals to 1. Next, for n equals to 2, which is I21. So this you have two segments, multiple trapezoid. Okay, what is the equation for multiple trapezoid? FA plus 2 multiplied by the middle one, 2. So in your data, the middle one is FM1 plus FB. Over 2. How do you get? 3 point? Yes, 3.43915. Tinggal tu. Okay, so that is I21 when n equals to 2. Now, moving forward, n equals to 4, multiple trapezoid as well. So, I31. Okay, H multiplied by FA plus the intermediate part. Okay, 2 multiplied by FM1, FM2, FM3. The intermediate part. Plus FB over 2. Okay, so that's why the first step just now you identify the data first.
step size, we take the highest one and adjust with the for each segment.
Step size.
Yeah.
The H.
Yeah.
Mhm.
So we take the highest n, right? Which is 4. So but this is
For this one, N4.
all.
Okay, remember that we should find each I. Okay, I go back to this. Okay, each I, we need to find the integral value, right? So each I has their own H. For n equals to 1, you use this H. For n equals to 2, you use this H.
So
Its own H.
each step size.
Yes, each step size. Each n has their own step size. So I3, 1, this is your step size. Okay, so the H here is different. Okay, it is not the same. So H is referring to their own segment. This H is 0.5. Whereby for n equals to 2, the H is 1. This one n equals to 1, H is 2. Okay. So this for n equals to 4, do you get 3.4456? Okay. Okay, that is the first level. Next step, move to level 2. This one, you need to use the Romberg formula. Romberg or Richardson extrapolation formula. Okay. So OH4, level 2. I1, 2. Okay, remember that for I1, 2, this one, I1, 2, you need the I1, 1 and I2, 1. Okay, I1, 2, I copy this table. Okay, I1, 2, you need this value. Okay, using the Richardson extrapolation equation or the Romberg formula. Just now that we have derived or calculated this one. I more accurate is 2, 1 minus less accurate, which is I1, 1. Okay. So I2, 1 is You get 3.4475. Okay, try to find I22. I22. Oh, 477. Okay, so for I22, you already can get 3.4477, which is approaching exactly the true value. Okay. You can proceed to level 3, or you can stop at here because you already find close to the true value. So this question, it doesn't mention until what level. Okay. Okay, if you want to proceed to O level, level 3, OH6, so you need to use the equation. This one, where is it? This one. This equation. 16/15 minus 1/15. Okay, this is the O level H6. Okay. Any questions so far? Yes, 4/3. Okay, for I22, because it is still in level 2. I22 is still in level 2, OH4. So that's why we use the same equation. Yes.
There's different probabilities.
I23, level 3,
So
different formula. Okay. Any questions so far? Okay, I'll stop here first so that you can digest the whole thing. Tomorrow we will go for final exam question. Okay, this one. I think it's in the slide also. I have uploaded. Okay, so this question, you see it only mentioned find until O level H6, which is K level 3. Okay, so you need to find the data first. What are the data? This one tomorrow we proceed. Huh? For which one? Approximate error. Current value minus previous value over current value. Okay, the error, it depends to the question. If the question asks you to find approximate error for each integration, then you need to find for each level and each estimation. Get it or not? But if the question asks you to find true error, meaning that your value with the true value. Approximate each level each level and each estimation and each level. Correct, yes. Okay, 6, yes. Error. True value, yes. Okay, let's see this final exam question. Okay, here it asks you to compute until OH6 means K level 3 and compute all true and approximate. So you must calculate all the errors. This one we proceed tomorrow. Yeah. 10 marks only. Okay, so enough for today. I want to discuss on your test date. Oh, how was your midterm yesterday? On Tuesday, okay? Good. Wait.